Oh hey, we're just doing refraction here.
Refraction, eh? It's got a
Boy.
wide range, actually. From heat waves to rainbows, double rainbows even, mirages, apparent depth, and cloaking.
But what exactly is refraction?
You tell me, buddy.
Well, refraction is the bending of light when it travels from one medium to another. One medium will be less dense than the other, and that causes a change in speed.
So does it look like the light's actually bending?
Oh yes it does. Crazy stuff happens in refraction, my friend. Alright, so I know we had an amazing intro, but I'm pretty sure a lot of you didn't follow, so I'll give you an example. Follow me. So as I said before, it all depends on the medium you travel from. So we'll assume that one of this medium is this wooden floor and the other medium is the carpet. Obviously the wooden floor is a lot smoother and hence we could say it's a lighter dense medium. So as you can see here, I am shuffling very easily in that first medium, and then as I travel to the other medium, it takes me more time and energy to travel. And as you can see there was a bending. Alright, so as we can see here, if we look at a straw in normal air, it would be fully straight, fully normal, nothing different about it. And if we put it in water, and we're looking at the part that it's in water, we'll find that it's still looking normal and not bending or anything. However, when we let it sit there and we look at it from a distance with half of it submerged in water and the other half without water, you can see the bending happening.
This is called apparent depth. The refraction can be seen when looking into a bowl of water. Air has a refractive index of about 1.003, and water has a refractive index of about 1.33. If a person looks at a straight object, such as a pencil or straw, which is placed at a slant, partially in the water, the object appears to bend at the water's surface. This is due to the bending of light rays as they move from the water to the air. This causes the pencil to appear higher and the water to appear shallower than it really is. The depth that the water appears to be when viewed from above is known as the apparent depth.
What does this mean? It's starting to look like a triple rainbow. That's a whole rainbow man. Double rainbow all the way across the sky. So intense. Double rainbow all the way across the sky. Oh my God, look at that rainbow.
A rainbow is a phenomenon that causes a spectrum of light to appear in the sky when the sun shines onto droplets of moisture in the Earth's atmosphere. It takes the form of a multicolored arc. Rainbows caused by sunlight always appear in the section of sky directly opposite to the sun. Rainbows are caused by light being refracted once in droplets of water. In a double rainbow, a second arc may be seen above and outside the primary arc, and has the order of its colors reversed. When the white light passes from air into the drop of water, the component colors of light slow down to different speeds, depending on their frequency. At the right-hand side of the drop, some of the light passes back out into the air, and the rest is reflected backward. Some of the reflected light passes out of the left side of the drop, bending as it moves into the air again. In this way, each individual raindrop disperses white sunlight into its component colors. So why do we see wide bands of color? As if different rainy areas were dispersing a different single color, because we only see one color from each raindrop.
So, light refraction phenomena, camo and cloaking. What is the difference? So first we're going to take a look at optical camouflage. This is known to everyone as camo. It's basically someone blending in with their surroundings, but really it's just made to look like their surroundings, but they're not actually doing anything. It gives the illusion of invisibility, but they're not actually mutilating the light rays at all. There's no refraction of the light taking place that's going to cloak it. There's also digital camouflage. This is a newer technology that uses digital cameras. And what they do is they take these digital cameras and they make a live feed video of what's behind the person that's going to be wearing the cloak, per se. And that goes into a computer, which goes to a projector. The projector puts it through two-way glass, essentially, which reflects that onto the person that's wearing the super reflective clothing. The observer then looks through the two-way glass, and they see what's behind the person reflecting off of them. So we're going to look at the applications of camo, and a well-known one is the hunting clothing that we see. Art design is becoming really popular, where blending in surroundings There's also augmented reality technology. That's what we saw before with the digital um, camo. There's also mutual teleexistence, and this is a new idea that's coming popular with metamaterials and the idea that we can create holograms of people. So a human user will get their like a live video shot into a master computer, which is hooked up to a projector that projects it onto a person, or not a person per se, but like a metamaterial object, which gives the illusion that there's a hologram there of the person. The same thing happens. It allows you to have like teleconferences that are like a live conference. It's like having someone there that could be across the world from you. So that's a new idea that's kind of new. But cloaking is the real refraction phenomenon that we're going to study here. It's using cloaks for invisibility. In Harry Potter, a famous series, he uses one. And people ask, is it real? And you say, yeah, it's from the principles of refraction. You can get negative refraction where it comes straight back. And that negative refraction happens in metamaterials, which essentially it's designed to have a negative refraction index. So it comes straight back. So when they make a cloak out of this, it creates a sphere in the center where the light rays are bent all the way around it, but it's only specific to a certain wavelength. So when they place the metamaterial ring around an object, you can see the yellow light rays are bent around the object in the center, essentially creating a cloak. So these are the wonders of light refraction, everyday phenomena of light. And this was created by Adam, Trevor, and Ahmed.